Hello guys, this is called approximating the standard deviation of a dataset given a histogram. So let me read the situation. It says that a community may be considered a sociologically healthier the more variability there is in its housing values, up to a point. A major newspaper in one city investigated housing costs in several communities in its area and is running a story on its findings. For one of the communities, a random sample of 30 houses. In here, guys, keywords. The first one is sample. We're using the sample formulas, not the population formulas. A random sample of 30 houses. 30 is the number of values we have, so n equals 30. Again, a random sample of 30 houses was examined, and the current market price of each value of each house was determined. The newspaper published the following histogram summarizing these 30 prices. In the x-axis, we have the current market price in tens of thousands of pesos, and in the y-axis, we have the frequency of each of these values. So there are 3 houses that have their value between 80 and 120 10,000 of pesos. So we have many information in here. Based on this histogram, estimate the standard deviation of the sample of 30 prices. Again, sample, keyword. All right, so first we need to calculate the mean because we're going to use it. This is pretty much alike to one exercise you did last week. If you have to calculate the mean of a set of information given in this way, you better calculate the mean of each of these ranges, because you really don't know if these 3 houses are worth 80 or 100 or 110. They are around 80 and 120. So we're going to say that those 3 houses in an average are worth 100,000, 10,000 pesos. So I'm going to do the same for all of this. This is easy because it's just the midpoint of each of these, right? Okay, so for calculating I was forgetting this. This means that there are 3 houses that are worth, in average, 100 of 10,000 pesos. All right, so in here we have 9 and so on. So we're going to calculate this, that is called the weighted mean. Remember, weighted mean equals, using the calculator, 168 10,000 pesos. All right, so for calculating the standard deviation, I'm going to do the complete calculation in here with the square root and everything. So remember, we have a 3 like this, so we're going to subtract 100 by the mean. So 100 subtracted by the mean and square it. And we have 3 of those, right? Because we have 3 of those of that kind in here. We have the frequency of that value. So we have 3 of these, and then we will have 9 of this. That is 140 minus the mean squared, right? And so on. I'm going to put some color in here, I promise, when I finish this. So this is the most important part, guys. We're going to divide by the number of values minus 1, since we are using the sample standard deviation. So we're going to divide by 29 and calculate the square root of all of that. Using the calculator, this equals 36.615. That is just rounded up to the nearest decimal place, is 36.6, right? So the colors that I promised. This number in here, that is the mean of the sample, is what you subtract in the part of the standard deviation. All of the other numbers are the mean of each of these ranges And what else? The frequency, these numbers are the frequency, so we have 3 of this kind, 9 of this kind, 12 of this kind, and 6 of this kind. And the most important part of all that I want you to remember is that we are dividing by n minus 1, since this is a sample standard deviation. All right, let me write the answer in here. 36.6. Please be correct. Oh, it is. Thank you. Thank you very much.